All right, so back to redox reactions. Remember that we said this was an electron transfer. And of course, we remember oil rig oxidation is loss, reduction is gain of electrons. So let's take a look at our sodiums combining with chlorine to form our sodium chloride. So to determine what's being oxidized, what's being reduced, we need to calculate our oxidation states. On the left side, we have sodium by itself. Anything by itself will have an oxidation state of 0. Same thing with the chlorine. All of our diatomic gases in their diatomic form are 0. Towards the right, now they're in compounds. And so we have this sodium. Sodium is a group 1 metal, so it's +1. Chlorine is a halogen, so it's almost always -1 unless with chlorine or other halogens. And then we simply look what happened. Right, the sodium went from 0 to +1. It's being oxidized. But we could also say that it's the reductant. Right, so the sodium is itself being oxidized, but it's reducing the chlorine, so it's acting as a reductant. So just be careful what the question is asking for. In terms of the chlorine to this chloride, that's going from 0 to -1, that's undergoing reduction. It's being reduced, but it's oxidizing the sodium. Right, so it's the oxidant or the oxidizing agent. See, magnesium solid with some zinc 2+ in solution will then form magnesium 2+ and then solid zinc. Obviously, the oxidation state of pure magnesium is 0, and then in its +2 charge, it has a charge, so now it's +2. The zinc 2+ starts as 2+ and then goes to 0. If we ask ourselves, what's the reductant and what's the oxidant? The magnesium itself is being oxidized, which means it's reducing something else. So the magnesium is the reductant. If we think about what's the oxidant, what's taking electrons? Well, the zinc is taking electrons. So the zinc 2+ is the oxidant. Note that the oxidant and the reductant are always reactants. One thing sometimes students try to do is try to, identify the products as the reductant or the, oxidant. That doesn't make any sense. These two are what's going on. They're what's going to interact. And then this is simply the result. So our oxidant and reductant are always on the reactant side of things, not the product. Redox reactions can also be very complex, and you'll learn how to balance redox reactions more so in Chem 102. So for example, if we had 3 chlorines plus 6 sodium hydroxides, that could go into a sodium perchlorate, 5 sodium chlorides, and then 3 waters, right? So we've got a whole lot of elements here. In order to find out, what's undergoing oxidation, what's undergoing reduction, we have to calculate the oxidation states for all of them. So what I generally do is I just pick an element and go with it. So this chlorine is 0 because it's by itself over here. On the right side, we know that the sodium has to be +1. And then this sodium will also be +1. And then this sodium will also be +1. We know that the oxygen has to be -2. We don't see any fluorines here. This is -2 times 4. And then we've got -2 right there as well. So then back to this chlorine over here that we're trying to find its oxidation state for. The oxygens add up to -8, and then you've got one of those sodium, which is a +1. So in order to balance all of those, we can see that this chlorine has an oxidation state of +7. Oh, my bad. I messed up the equation. This should only be a 3. Change this to a 3. And then this changes the oxidation state to +5. Chlorine can have an oxidation state of +7 as well in perchlorate, but here we just have a regular chlorate. My bad. Cool, so we have a +5 there. If we think about this chlorine over here, the sodium is +1. The overall molecule is neutral, so the chlorine must be -1. And then finally, the hydrogens, it's with nonmetals here, right? +1. It's bonded to that oxygen. And then here it's +1 as well, times 2 of obviously to make the charge equal. And then if we think about what's undergoing oxidation and reduction, well, the chlorine is actually undergoing both. Right, so that's also an option. Some of the chlorine is undergoing oxidation. Some of the chlorine is undergoing reduction. So there's just another example of a pretty cool reaction. Let's take another look at another one, a more conventional one, where we're going to have an oxidant and a reductant. So we've got 5 sulfites combining with 6 H pluses in the presence of 2 permanganates, turning into 5 sulfates, 3 molecules of water, and then 2 manganese 2 pluses, right? We don't see any fluorines anywhere, so we can be safe with our oxygens that they're going to be -2. So we've got -2, we've got 3 of them here, we've got a -2, we've got 4 of them here, we've got a -2, we've got 4 of them here, and then this one is -2 as well. The hydrogens, they're not with any metals, so they'll just be +1. This hydrogen over here will be +1 times 2. And then let's keep going with other stuff. Next up, we can go with the sulfur. In this case, this sulfur, note that the overall charge is -2. We've got 3 oxygens with a -2 charge each. If you calculate the oxidation state, that'll be +4. Let me change colors to match my notes. +4. And then if we think about the sulfur over here, now it's got 4 oxygens attached, still has a -2 charge overall, so its oxidation state is +6. So we can tell that the sulfur has undergone oxidation. And then finally, the manganese over here in this permanganate. Permanganate is a very powerful oxidant, and the oxidation state of this manganese right here, if you do the calculations, you'll get +7. Over here, it's by itself and has a charge, so it's +2. So it is undergoing reduction. And so if you think about how you talk about this in real life, you would say maybe something like the sulfite, the SO3 2- reduces the permanganate, the MnO4- to Mn2+. Or you could say that the permanganate oxidizes sulfite into sulfate. Either way, right, our oxidant is the permanganate because it itself is being reduced, but it's oxidizing something else. And then our reductant is our sulfite, right? It's reducing the permanganate and it itself is getting oxidized to sulfate. One more example. Got this dichromate. Interacting with some acid and some iron 2 ions. To form this chromium 3+, some iron 3 ions, and some water. So again, let's go ahead and calculate all of our oxidation states. We don't see fluorine anywhere, so we can assume our oxygens are -2. There's 7 of them there. Over here, -2. Hydrogens, we don't see, they're not attached to any metal, so they can be +1s everywhere. And then our molecules of interest, right? Note that we've got 2 chromiums here. The oxidation, the sum of from the oxygens is 14, but it has a -2 overall charge. So this charge is +6 for each of them. And then, of course, there's 2 of them. And at the end, in the product side, they're by themselves, so it's just +3. So we can see that the chromium has undergone reduction. terms of the iron, it's by itself here as a +2 charge. And then over here, it's also by itself as a +3 charge. So we can tell that the iron has undergone oxidation. But remember, what it undergoes is the opposite of what it does to something else. So our oxidant here is the dichromate, the Cr2O72-, and the reductant is our iron 2. So these reactions can be tricky, just get some practice, and they shouldn't be too bad.